Let's take a look at how we analyze multinomial outcomes. Let's use an example for this. Let's assume that you're looking at the association between smoking and diabetes, and you construct a 2x3 table. Smoking status, smoker or non-smoker, is shown on for each row. Let's just say you have 3 studies. They all use the same sample size. However, diabetes is measured differently. In the first table, we have 3 categories: gestational, type 1, and type 2. In the second table, we have whether it's controlled, like low, medium, or high. And in the third table is the blood glucose level or glycemia at 90, 120, and 150 milligrams. Think about these 3 tables and think about the variables that are being used. What type of variables are these? Now, smoking is dichotomous. What about the other one? So in the first table, diabetes is more of a nominal variable. In the second and third table is more of an ordinal variable. There is an order. Well, what's the difference between the second and the third table? The difference between these is that low, medium, high doesn't give you exactly how much distance there is between one category and the other, whereas 90, 120, and 150 milligrams is a precise distance between categories. So the second table is not evenly spaced, whereas the third one is evenly spaced. These 3 types of studies require different types of analysis. In the first one is nominal, so we will use a prog-freq with the scores equal table, which is the default, so we don't really have to write it. And we will look at the general association results. For table number 2, the outcome categories are not equally spaced, and so we will use scores equal mod read-it. And we will look at the difference in raw mean scores. For the third table, outcome categories are equally spaced, and so we can use the default scores equal table, and we will look again at the raw mean scores differ. So again, for a multinomial outcome, think about whether it's nominal, ordinal, but not equally spaced, or ordinal and equally spaced. And you will analyze it differently. In SAS, we use prog-freq tables, smoke by diabetes. Let's just say that these are the names of the 2 variables, and then /CMH and scores, and then run it. Scores will be either the table default, which is the default, so we don't actually need to write it, or will be the modified read-it. You will use modified read-it if the outcome is ordinal but not equally spaced. After you run SAS, you will see this type of result. So now you have 3 different options. You have non-zero correlation, raw mean score differ, or general association. In this case, we used table scores, which is the default, and you can see there is nothing written here because we're using the default. So which p-value should we use? For a nominal or ordinal with equally spaced categories, we can use the scores equal table. So this is the default. We don't have to write it, but it's written here to show you, which actually shows in here. Now we select the p-value. If it's a nominal outcome, we will use the general association. If it is an ordinal equally spaced outcome, we will use the raw mean score differ. And so the 2 p-values will be different. If the outcome is ordinal but not equally spaced, you need to write scores equal modified read-it, mod read-it. And then you will select the raw mean score differ p-value of 0.0116. Now practice using SAS. Calculate the p-value for the 3 types of scores, either put in none, scores equal table, or scores equal mod readit. Take a look at the p-values. Are they different? And given that they all use the same data, which test is more powerful? So next time you calculate the p-value for a variable, for a categorical variable, you always want to ask yourself, what type of variable is this? And if it is ordinal, you might not want to use the chi-square, which assumes that the variable is actually nominal, and you lose power. Now keep in mind that when you set up the table, your outcome should be, the category should be in different columns, and then you're going to look across the rows to look at the row mean score difference. If you set up the table the other way around, and you can try that, you will see that you will not get the same results.